Pregnant pause. We're going to wait for slides, I guess. All right. Hey, everybody. Nice to see you here. I hope you're having fun at the DevFest. So today we're going to talk about a subject that's near and dear to my heart, but also that very few people know about, the demo scene. So this particular talk is going to explain a little bit about the history of the demo scene, what is it, and how to start exploring creating real-time graphic effects, which the demo scene is all about, in Kotlin. I realize I don't even have an intro here. My name is Etienne Caron. I'm here thanks to the generous sponsorship of Google through the Google Developer Experts Program, so I want to say a little thank you to them for that. And let's get started. All right. So what is the demo scene, right? If you've read the abstract, it's an international computer art subculture focused on producing demos, which are self-contained computer programs that show off the programming, visual art, and musical skills of the people that built them. So what did this look like? Where did this start out? So with any luck, we're not getting an animation. Anyway, so this demo scene can be tracked back to what were called cracktros and crack screens. So those were short demos that people would, software crackers, the people that would bring video games to the masses in the 80s, who removed protection for computer games, they would swap out the protection effectively with small little programs, like basically electronic graffiti, just saying, hey, we're the best, we're so awesome, we cracked this game, hello to all my friends, and so on and so forth. Pirate groups would often start to diss each other through these cracktros. I've seen more than one cracktro with long-winded rants about so-and-so not really giving them good quality diskettes, and you know, sometimes you feel maybe it's serious, maybe it's not, who knows, but it was generally kind of funny to read. So, of course, you have to think back to the 80s. Modem speeds were pretty miserable, and the internet was not really a thing. So if you're a kid in the northern hemisphere somewhere, you literally have to walk kilometers in the literal snow with your computer equipment to get access to reasonably priced software. So I'm hearing a little cracking, but whatever, I'll keep going. So these were great opportunities to learn a fancy programming trick or two from your friends and peers. So given you had a whole bunch of computer nerds meeting infrequently in Meetspace and the absence of social media, is this me? Sorry, I'm guessing it's quite unpleasant. Yeah? All right, well, we'll soldier on through. I think it's going to calm down at some point. Yeah, oh, microphone, yeah, cool. This, you guys, okay. Are we on? Yeah, all right, cool. All right, okay, cool. So, where were we? Yeah, great opportunities to learn your fancy trick or two from your friends, right? So, also you have to think back, no internet means when you want to learn programming tricks, you have no peers, you don't have any search forums or any of that stuff. So effectively, that kind of stuff happens when you're in person in Meetspace and just meeting with your friends. So, you know, this is all the perfect recipe for fun, all these parties, except, you know, when something happens like the cops busting in. So, you know, what happens then? From what I read online, that specific party, the police somehow decided to forgive these hardened criminals. I mean, if I'm looking at the picture, I don't know if I see anybody above 14 in that page. From the entry that I linked in the, I believe, Norwegian here, this party was organized by demo groups that are even still known today, which back then were cracktro groups. Razor 1911, The Cartel, big serious names here, The Abnormal, C64 groups. So about 150 people attended this specific party. And the police, well, they stopped by to warn the attendants that, hey, we're watching you. We know you're copying games, and that's not correct. So we're going to watch and make sure that that doesn't happen. But you can still have your party and everything. So that was all covered in this newspaper back in the 80s, which was one of the bigger newspapers in Norway. And from that party, this was the winning demo. With I don't know if we have sound here, but anyway, whatever. So this was a solid 6-minute entry, which to my Philistine eyes seemed to have some fun scroller effects. There's the chiptro music going on there. That probably pushed the limits of what was known for the Commodore 64 back then, I'm pretty sure. So I'm not going to play the whole thing here, but if curious, there's a link both to the YouTube where you can see it and to the actual C64 software that you can find over at the Internet Archive now that it's back up after the events of a few weeks ago. So at the end of the day, the concept of the demo party, as you can guess, had a lot more legs to it than the shadier copy party part, right? They could end the party even if the police was watching them, and they still had fun and still did something positive for once, I would guess. So as demo sceners started to get their hands on more and more powerful hardware, at that point like the Atari ST and the beloved Amiga, demos and intros started to get more and more impressive. So here we have an invitation an intro as it was known back then, to a Dutch party. And we also have some footage from a big Danish demo party called The Party, originally enough. And so if you fast forward in time, this is what a demo party starts to look like by the mid-90s. So those European demo parties are huge at that point. You know, some parties reported thousands of attendees in the late 90s. The competitions actually become big deals with cash and hardware prizes, big sponsor deals, live shows, big productions. The hardware manufacturers actually sponsoring those parties and giving away hardware to the winners, showcase their equipment. So we're going to little break from the, I think my sound is getting choppy, but that's fine. So we're going to take a little break from the history. I think the microphone is kind of chopping out a little bit. Help. Well, I guess it'll be fine. All right. So break from the history lesson. I'm going to try to use both hands to show you how you can build your own little demos using Kotlin. Well, I don't know. I think, yeah. Let me just like, hello? Can I actually put down the microphone? Can we go back to the, can we go back to this? Because I need to put this down so I can actually show some code.
Oh.
And it's cutting out as well.
Great.
Sorry.
Isn't technology wonderful?
Yeah. So I think we'll try this with the glitchy audio a bit, maybe?
Okay.
Yeah. So I'm guessing console's going to, yes. Like that's les gens à la régie that paying attention. I don't know how to say that in English. The wonderful people in the back room doing all the hard work. All right, so I'm going to switch to to screen mirroring. So sorry for the technical problems, but you know, that's life. Show will go on, I promise. Okay. Let me just like adjust the font. So I'm going to need audience participation at this point. Is this readable? Yell out because I can't see any of you. Awesome, cool, thank you. All right, cool. So here I'm gonna intro you to like the Kotlin software I'm using today. It's called Open Render. That's a library that allows us to do some real-time graphic encoding. And I think that's, if there's one technical takeaway from this talk today, it's really that you should check out Open Render. Wonderful open source project. It's backed by a nonprofit company out of Holland. I've met the founders and they're really sweet people. So I really want people to start discovering this nice little stack. It's pretty cool to play around with. So let me start by demoing a little bit what I'm talking about when I'm saying live graphics here. So I can just start a little piece of software here. All right, so we have a window. It's not showing much right now, but that's on purpose. So we have what happens is that with this software, what's kind of interesting is that we can start live coding a few things. I'm going to do one little change here. So I'll specify the window will always be on top. So when I'm coding, you'll be able to see what I'm doing. And one of the things that's really kind of powerful about this platform, this API, is that once you start messing a little bit around with it, you can do live changes to your code, and they're going to show up live in the actual window. So let me just like find my bearings here a little bit. Am I running the actual right program? Yeah. Cool. Well, actually, I seem to have a bit technical problem, so I'm just going to go with like the baked example. No, that's not the right one. Wrong conference. I'm sorry. Cool. All right. Going back here. So what's kind of interesting is that if we start looking at the different pieces of code, I can just say change the color here if I'm interested. So I'm just going to go with like, something a bit more colorful, like 5.5 right there. If I save this, we should see live change of color. Yeah, cool. All right. The other thing I can do is I can specify, I want this window to be transparent. So if you've looked a little bit at the code behind it. I'm going to restart this again. All right, so we have a transparent window, so and that's kind of fun. So we'll be able to look at the code as I'm typing without having anything blocked out, so that's cool. Next up, so let's say I want to write a little message to everybody here. I want to make sure that we have it shown up somewhere. Right here. Right. I'm actually realizing how boring this is right now. So my technical demo is not going so great. I'm a bit distracted by the sound, I have to admit. So what I'm going to do is just like go through like my pre-baked examples in a sec. I'll go back to the presentation. I have more fancy examples coming along, and we're going to start looking into those in a sec. Meanwhile, I just wanted to go back here. All right. All right, cool. Stop turning my head. All right, I'll try to not do that. All right, so back in the other days of demo coding, everything was pretty much done in assembly code. It's not how that works anymore. I've talked about Open Render. I just want to put the link up here right now. So this is the platform you're going to want to be playing around with on your own to sort of discover all these things. If I go to a few of the key features, like the TLDR of this library is that it, are we good?
Hi.
Hi. Yes?
We're just going to take a 5 minutes so we can fix this mic problem, and then we'll be right back.
We're back. I'm going to keep going here. All right, we're back. So, yeah, so I've talked about Open Render a little bit, mentioned it's a project that was launched in 2018, and the lead developer of the framework, which I've met a few times and I find quite friendly and nice, is Edwin Jacobs, if ever you're looking it up. So, nice guy. He's like happy to answer questions on the GitHub if ever you're curious. He's been a great help. They have a very nice Slack chat that I encourage you to join, etc. All right, so yeah, we went through a little bit of the live coding with the problems I had, and we're going to go global at this point. I'm going to talk a little bit more about the history of the demo scene before we get to the next steps of hopefully a bit more impressive demos. Right, so first thing you need to remember if you were here or know about if you weren't there is that a big hardware revolution was taking place in the early 90s. So we had faster computers for sure, right? That's always been pretty much true. But modem speeds were going to like go up exponentially. So, you know, in the early days we had 300 baud modems. That's like not a whole lot. And in the early 90s we started seeing 14,000 baud modems, which actually made the idea of you know, transferring software like bigger than a tiny little floppy over the phone lines possible, and also made eventually the internet access possible. But before internet came along, you had the BBSs. So BBSs were actually very crucial to the growth of the demo scene, and with the faster modems, that whole demo scene thrived, right? We could finally share bigger productions with everybody around the world. So there's a rich pre-hit internet history here that goes way beyond the demo scene. If ever you're curious, I really suggest that you check out the BBS documentary, which was made by the digital archivist and historian of technology, Jason Scott, pictured here. Funny story, we had Jason in the cow suit in 1995 at a demo party we organized in our own hometown in Montreal. So that's like my first introduction to him. I think he's a lot more dapper with the hats. So anyway, part of the BBS ecosystem explosion, we see birth of a lot of quirky demo scene adjacent art forms. So if you think back to BBSs, you might not know, but they were all text-based. And that's where we see ANSI art groups make their apparition. Text-based BBSs, you know, they were kind of boring to look at, pretty black and white. So quickly people took to making doodles and graphics and fancier and fancier stuff with the ANSI character set. So you can see like a pretty nice example here. ACID is actually a very well-known group. If you look them up, they've even been featured in the last few years, like on The Verge and things like that. So They have like pretty funky stuff still going on today. They're still going on strong. So once ANSI color codes were adopted, you started seeing all these ANSI splash screens everywhere when you were logging onto BBSs. After ANSI art productions, you started seeing the apparition of what were called disc mags. Disc mags, here's one pictured, like a very popular one called Hoogie. It was started in the mid-90s. So the content was mainly based on contributions from the readers, and was only proofread and formatted by the editors. So you had topics like graphics programming, demos, demo parties, programming, and you had even some disc mags having talking about the different demo party reports, the politics of the demo scene, literature of all sorts of weird little bits. And so you have to keep in mind that this was all like pre-modern web. So you didn't have really HTML back then. That wasn't a thing. So if you think of Cracktros, the original Cracktros as graffiti, disc mags were like digital fanzines, effectively. And so with demo group coders pushing the limits with display hacks and crazy optimization tricks left and right on early machines, musicians keep pushing the capabilities of sampling on these machines and create their own music formats and editors. So what you have pictured here are Screen Tracker and Fast Tracker 2, both created by demosceners, which were like pretty interesting pieces of software to develop your own music. Still nowadays is like an active scene of tracker type music. If you start looking into it, it's kind of still active and going on. At the top, you had like two very popular pixel editor programs that were around back then. So Graphics 2, and you have well, actually only the one shot. I don't have the other thing here, but you could sort of see how you could edit stuff even if you had like 320 by 200 resolution on these computers, right? Effectively the groups that start creating all this art, keep in touch through the BBSs, and that's where I was really originally exposed personally to the demo scene in the 90s, and built lifelong friendships, people I still chat a fair bit with today, and keep meeting up even in my 50s now. All right, so let's just go back to more technical bits and start hopefully getting to working demos. We're going to put ourselves in the shoes of an early 90s demo group. So you're putting together your demo. Like you need your storytelling, your cinematic effects are coming in from everywhere. You see the scene, everybody's like doing more fancy productions. So how would the demo building process look like? Well, clearly a theme is nice. Scrollers, as we saw for the Cracktro, won't cut it anymore. They're kind of boring. People want to see fancier stuff. So, at that point, sceners have started making the distinction between these really small productions and calling them intros at that point. And you got bigger and bigger productions called demos that would fit on full floppies, whereas intros typically were sort of under 64K. Like that was the whole sort of concept of competition that started coming up. So if we gather our team up, and in my case, I'm from the town of Montreal, like we're going to brainstorm like a mood board here. And as you can see, we pick a retro aesthetics and our home city of Montreal as inspiration. Then we're probably going to find a pixel artist of some kind and start like making visuals. So we picked a few of the Montreal landmarks. You have the 5 rows, Farine 5 rows there featured in the little front. And that's a little bit less well-known feature in Montreal, the milk bottle. So that one's been retouched and revamped in the last few years. It's like close to the old port area of the town, if you know the town at all. And so to create our composition, going back to thinking about our demo, we're going to use something called fragment shaders, which I'm going to show you in a minute. So strictly speaking, fragment shaders were not available back in the 90s. That's not the kind of thing you had access to. But they've sort of brought the attention back to the demo scene because they really sort of, as you'll see in a minute, sort of bring back a sort of way of working with graphics that sort of fit with like the more 2D way of doing things back in the day. Right here, you're seeing a screenshot of a website called Shader Toy. So when you're writing shader code nowadays, Shader Toy is effectively the Wikipedia of shading programs, or a bit of a mix between GitHub and Wikipedia, if you will. So what people do is that they bring up their shader code on the browser. You have a little editor that you can see on the right, and you can live see the results of the code that you're running in the web browser for your shaders. So here we have a Menger sponge. It's a fractal type of structure in 3D that's being displayed. And there's a lot of fancy programming techniques behind this, but if you look, like this program is actually like a couple of hundred lines of code long, and it can produce very fancy graphics. So let's try to sort of get a head into how fragment shaders work, because I think that's kind of a good intro point for a lot of folks. So we're going to try to go back to my live demos, and then hopefully this time we're going to get a bit more impressive outputs out of this. So let me just focus back the screen on single screen right here. All right, I think the font sizes are still good. And now I'm going to jump into more of the shader toy explanation piece of code right here. All right, let me start this. Okay. So right now, not much going on. I programmed this specific program to be able to show you various types of shaders in action. So one thing I'm going to do, though, that's kind of tiny to sort of give people a good impression. So I'm going to just restart this, put it the right size. All right. So a little bit more visible right here, right? All right, so we have different effects. So shader toys can be like very fancy, and while shader toys are in the web, this is effectively a way of replicating shader code inside Kotlin, inside this OpenRender API. So we have a few fancy examples here. For a sunset, we had like a fractal traversal right before this. We can have these nice fancy effects going on where we're just playing around with mathematical functions. And so we're going to try to give a feel of how do you get started in shader programming today. So let me just go to my blank shader. So one thing I should mention is that we'll be putting up the links to all of this code in a bit, if that wasn't sort of obvious at this point, like sometimes, need to mention it. Right here, I see a piece of code, right, that sort of helps you pick through the different shaders. And the one we're interested in right now is this talk live edit.frag. So what is a frag? What is shader code? What does it look like? Let me show you right now. So I'm running a plugin in my IntelliJ IDE right now, which is able to sort of highlight shader code. It's called the GLSL plugin that I've highlighted just here. And so what this plugin allows us to do is take this shader code, which is usually code that you upload to a graphics card and that manipulates the GPU to create graphics, and will give us a nice syntax highlighting. It will give us, typically you're able to get help on like the F1 function key working to explain what the different variables are. But if I had to explain it in a very simple way, shader code looks a lot like C. Like you can see that the syntax is very similar. Defining functions is fairly similar. Here we have our main. So if you're familiar with C, most programs start with a main. In this case, it's a slightly tweaked version of main called main image. And what is it doing right now? As you can see, it's a blank white screen, not super interesting. But what this does is a function that you call for each of the pixel coordinates you have in your grid, and will bring back a color. So right now, it's actually literally being called for every single white pixel you're seeing. This function resolves once and will respond with white. So the code that does that here is like right here. We specify a color, and then we output it with a certain transparency value that isn't working really right now, so it might as well be 1. And when we just change this around a tiny bit, let's say we want to do something a bit more interesting, we want things to be green, then I change this vector right here. And what's interesting here is that the live effect, as you see, was refreshed. Like we see instantly what the color change is. So not super exciting stuff, but at least you start to get the picture a little bit how this stuff works. So to make things a bit more interesting, we're going to start varying the color in time. So what I'm doing here is I'm calling a cosine function. I'm taking a parameter called time that's defined in my fragment shader. Like that's a global variable of sorts in my environment. I'm getting a time tick for every time frame. I'm taking my color coordinates and I'm adding some slight vector coordinates that I won't dig into too much, but the main thing you have to remember here is what I'm doing is cycling the colors in time. So I'll just save this and show you what that looks like. And there we have it. So you might be wondering, oh, that's odd. Why are the pixels showing different color depending on the coordinates? And that's the bit here that you have with the little vector math that's going on here with the x, y, x. So depending on the actual coordinates that we're getting, so if we're pixel in the middle of the screen, we sort of get a slightly different color, and it gives this nice little hue that's going all around. So that's like our very first basic shader code. Now, if I want to get a bit fancier, I'm going to go back to my shader tool right here. I'm going to start doing something called sign distance field, something I'll explain in a few seconds, but I think it's interesting to just show off how they work and what they do right away. And so this is assigned to my hotkey 6, so I'm going to show this here. So it's possible to write fragment code that will give out geometric shapes like this. So that might seem like black magic when you haven't played around with these things. It certainly did to me when I started out. But I'm going to attempt to explain it in an understandable manner right now. So what we have, we're still at our main function right now, right here. And so we play around and try to find out, like we just get a few math things done to sort of find out what's the center of our image. So we do this by taking our resolution, finding out what the x and y here in this case are width and height, right? Dividing that by 2, it sort of gives us our center point. It's a 2D vector that identifies which part of the center. And we do this little math just to sort of basically being able to create a 2D graph. So if you're looking at the screen, imagine that there's a plot in the middle point is 0, 0, and that there's axes x and y as you're used to in math, and then, you know, if you're if you're in the northern quadrant of the screen, y is positive, the south quadrant of the screen, y is negative, and so on and so forth. So the way that we can determine if the pixel is going to be black or white and actually have it come up as a shape is by using these signed distance functions. So what you do is you pass in the coordinates into this function. In this case, you get fancy. The star is rotating, so I even pass in the time. And so that allows sort of the signed distance function to determine that for this screen coordinate, am I inside the star or not? Am I inside the circle or not? Which is a slightly simpler sort of way of working with things. And if I am, then if the result is true, the coordinate should be in the circle, it's going to come out as black, and if not, it's going to come out as white. So the signed distance field here literally quite means how far are we from a geometric shape, and by that we can sort of determine which color we should assign. So that's all like fairly, abstract stuff. So I'm going to try to show you visually what that looks like and sort of build a better intuitive feeling of how you could play with these things yourself. So I'm going to go back to the keynote right here. Oh, actually, I should shut down the program right there. Yeah, there we go. Otherwise, we'll have sort of spinning stars around. So how do signed distance fields work? For me, it was really voodoo until I saw this specific page that was explaining it a little bit. So if you're trying to determine if x and y are inside a circle, the function is quite literally this simple. You just, as you might have expected intuitively, you just need to find out how far you are from a central point. And if the circle has a radius of 2, then if you're further away than 2 from the center point, then you're outside the circle. So that's effectively how signed distance fields work. So you pass in x and y. You also tell it we have a circle that's, you pass in your own x and y that you're trying to test. You pass in the x and y of your circle, the radius of your circle, and from that you can determine, hey, is this point inside or outside? And so what's kind of fancy here is that they're using signed distance field with like these little waveforms, so you can sort of determine more than just if you're inside or out. You can determine how far outside you are or how far inside you are. And so you can start making rules that say, I'm going to vary my coloration of pixels depending on how far I am from the center. And this is how they came up with these little graphics that we see right here. So if you're interested in sort of learning more and digging deeper into all of this, what I suggest you do is you go visit the shader toy page I linked here below. It's showing off all the signed distance field primitives in 2D that you can use to generate these things. The other thing I'll recommend that you explore a bit more to really dig in deep is the book of shaders right here. That's like a very nice tutorial that you can go from knowing absolutely nothing about shaders and GPUs to getting to the point you can do not necessarily the fanciest graphics around, but having quite a lot of fun with like a very little amount of code and start experimenting yourself. And hopefully you'll check out the repo I will provide in a few minutes, and you'll be also able to sort of use that framework to start testing like actual fragment shaders right away without necessarily mucking around, creating your own shell programs and all of that. You can also always go to Shader Toy and start straight coding into the browser and having fun with that. So I'm going to touch quickly on music, which we're still missing if we're actually building a demo. I'm looking at time here, so I'm going to try to keep this short, but I just wanted to bring up a bit more history. Right here, what you're seeing is like a Fairlight. So the Fairlight was like used in the music, well, music. It's like a very small little funny music. I don't want to bring the expectations too high, but a friend of mine recouped this old Fairlight and actually used it to make a track that I've put into the little sample code that you'll see here today, and that's also part of the repo. It's actually a pretty storied piece of equipment. If you're curious, I recommend you check out this article. It was used like in big productions back in the day, like Peter Gabriel used it to do stuff, like all sorts of very popular musicians used Fairlights across the years to make really fancy stuff that you can now all do in Pro Tools with a Mac, but you know, it's still like kind of an interesting piece of history. So to add music, well, I'm going to jump back a few seconds just to show you. It's going to be 2 lines of code, but it's kind of worth showing how easy it is to do these things. To add music to your OpenRender code, OpenRender adds more than just graphics. It allows you to do MIDI, it allows you to do all sorts of fancy stuff. And let me find my way home. Yeah, I have these baked examples. So the image you should have here is like Martha Stewart coming out with like, and this is the turkey, and puts the turkey in the oven and goes in the rack underneath and brings it back out. So this you can find the fully baked code as part of the repo. Basically, the music needed, the code needed to play music is only what you see here. When you start your program, you just need to effectively instantiate this minim function, and once you have that, you load a file, you start play, and your MP3 is going to be playing, and that's about it. So, you know, if I had more time, if this was more of a programming workshop than a 40-minute talk, we would go into how you can sync the music with your graphics, which really gives quite a unique feeling and starts really making it come together, but we're going to skip that today since we don't really have the time. All right, so nowadays, in the 2000s and beyonds, the demo scene is still around. Demo parties have gone big, as you can see. There's less of these huge events nowadays, but I would say that this kind of event was kind of fairly typical right up in the 2010s. And after a while, I think, started becoming big, more niche affairs. Still pretty big parties. I hear about parties every year that have thousands of attendees, but you know, they no longer fill out stadiums like this. I'm sad to say, really. And the other thing that changed a lot is that we're now using really super high-powered graphic cards. The 2080, I realize, is kind of dated at this point, but you know, we have access to really crazy hardware, and if you start looking into the demo scene of today, you'll see that the production have gone like at a totally different level. The other thing that happened since then is that the sponsorships have gotten much bigger. I actually got in touch with a lot of demo sceners at this specific event. It's like from 2015. It was an NVIDIA hosted event. NVIDIA sponsored everybody to like, flew over old demo sceners to San Jose and hosted everybody. It was like an event inside the big NVIDIA event. They had like a full-on demo competition, and more interestingly, a whole lot of tutorials and seminars on how to program these things all day long, which you can still find online today on YouTube. So if you're curious, I recommend, again, checking out that link. And another thing that's sort of becoming a bit more common in those days was the use of sign distance field to jump from the 2D world I showed you earlier to the 3D world. And so I think, yeah, with time, I have time to cover how these work, because I think we're not going to jump into code here because it's a bit too complicated, but I just want you to get the theory behind it, because you can do really fancy things with this technique. So the graphic you're seeing right here at the top is all made up of math functions. This is not a Blender-built 3D meshed thing. This is all sign distance field and all done with mathematical functions like I showed you earlier, that describe like how far you are from a geometry and where things are. So you might be wondering, okay, I get how this could work for a 2D graph, right? The point in the 2D graph is either inside or out, but how could this work for 3D? How do you jump to another dimension with that kind of technique? And to do it efficiently, you use something called distance-aided ray marching. So what is distance-aided ray marching? So here we have conceptually in black shapes that have been defined. Imagine that instead of being in 2D, they're actually in 3D, but you know, it's more easy to visualize in 2D. So what you do is you take a specific point, which would be where the eye of the observer in your scene is, where your camera is. And you start for each of the pixels sort of again in your grid by sort of making this mathematical construct where we have the eye here. You have the pixel that sort of makes a line. You draw this line in 3D in the space, And then you use your sign distance field as 3D objects to sort of determine if that line is going to hit an object or not. And that will say to the fragment shader, that's the color my pixel should be because it's hitting that thing under certain conditions. Now, the way you can actually do this efficiently, and which is the great trick that demosceners have, and the person behind this is the person that built ShaderToy, I should say. So the great insight was that if you had to calculate that mathematically, it would be way too heavy and you couldn't actually render scenes efficiently. The insight here was that by marching along the ray with specific amounts of distances and testing if you were inside or had passed a specific geometry, you can sort of find out if you're close enough. So what you do is you take your ray and then you go, okay, I'm going to walk a certain amount on it, and I'm going to test if I'm inside or outside. I'm going to test which distance I am from the object, which is actually quite fast to calculate. If you're not yet close to the object, you keep testing, but with smaller and smaller increments. And so that allows you to throw your ray and sort of determine pretty quickly, without being too heavy of a calculation, if, you know, how far you are, like which basically item you're hitting by projecting that ray into space. I'm going to skip the live coding exercise here because we just don't have time. But the idea is that in those shaders, you can write code that will, once you have the basic code that does this ray mathematics and this ray projection, you can start building your own scenes by adding up sign distance field functions. And you get results like these that you can see here. So again, a good link to link to understand all this stuff and actually get a good feeling for it. What's kind of wonderful with these things is that you can start describing really fancy geometries with very little lines of code. If you want to define a sphere, it's effectively one line of code. You just say, I have a sphere, it's this place in space. And once you've defined all your objects and potentially also what texture they're supposed to be, you end up with like a fragment shader that can actually render things without having actual geometry or meshes involved in all the programming. I'm going to end. We're getting close to end time right here. I'm going to close by sharing a few things that I actually love about the demo scene, and I think that you should find out about. So I love how it's always reinventing itself every time a movement kind of seems to slow down. So Razor 1911 is, funnily enough, they've been around since the mid-80s. They were part of the organizing party I showed at the very beginning when they were like young kids. And I think it holds the record for being the longest running pirate software group. So that's a dubious achievement, but at the same time, they're very active in the demo scene. It's kind of cool to see what they do. I'm quite a fanboy of both the old and the new demo scene work. Like, they have like really nice little demos. I don't have an active link to that, but if you check that one out, it's really cool to check out on YouTube. And they even, you know, some of the musicians for that group publish their own vinyls, which I'm quite a fan of. That last demo, if you notice quickly in the title, said that the demo scene is dead. So it's a bit of an in-joke in the demo scene. The demo scene dies every 3 years, and effectively means like whenever somebody gets tired of contributing to the demo scene, it's kind of pulling back, we'll call it dead. It's like, oh, it's dead. Maybe it's more like it's dead to me. But, you know, after a while, people just laugh at that because the scene has been called dead like every 3 years, effectively since 1985, right? So the reason it's a joke, it kind of misses the point because the whole movement is about reinvention. So if you think about it, I talked about the ANSI groups a bit earlier. This is the stuff that's been posted and featured in The Verge. So kind of crazy scrollers still operating with like old school BBS technology. You still have sceners that are pushing the limits of the old hardware even today. So there's still active groups for the Commodore 64. There's competitions every year for like Commodore 64, Atari STs, Amiga, MS-DOS. All these things are actually very much alive, and people are writing crazy new effects for these things. Like, you would see some of those demos, you would not believe they're running on C64s. You time travel back and show somebody that piece of software, and they would be like, the mind would be absolutely blown. And there's this kind of stuff. So this is a demo that was made using not an actual 8-bit computer, but was made using the floppy disk, and they reprogrammed the floppy disk reader of the Commodore 64 so that it could push out a signal to CRTs and generate the music that we're hearing now using the head of the C64. So if you've ever seen those YouTubes where they make nice music with toothbrushes, it's kind of the same idea here, except they managed to build a whole signal out of the thing as well. And I'm going to end on this. Like, in all, the demo scene's future is, even though everybody keeps calling the scene dead internally, it still looks kind of bright to me specifically. They've recently been actually recognized as a UNESCO culture, so in both Finland and Germany. So there's actually quite a few other countries that are sort of taking out the old Demoparty records and trying to apply for UNESCO status to be recognized as a proper cultural thing. So I'm going to end on one more thing. If you want to find out more about the demo scene, we're over time. I recommend you jump to this specific YouTube. It will sort of give you the insider life of a demo scener from A to Z, and you'll get to have a much more in-depth look into how these things work, and the kind of fun people that are operating in that sphere. Thank you very much for your time. I hope you enjoyed this, and if I have questions, I'll be around. You bet. Code up. So I'll just impose on the AV crew one more time. I think they heard me. Is that okay? Showing, yeah? All right, cool. So this is a branch of a repo I run with all the sample code from today. I realized we had to go really quickly over it, and so it's probably better off if you just go and check that out if you're curious. You'll get a nice running start with OpenRender. And frankly, even if you don't go check out my code, OpenRender as a library is quite like a nice discovery. So, and they have a lot of nice tutorials on their website, so it's also a good way to go. The link is not working. All right. So 404. Oh my God. All right. So okay. We're gonna improvise a little bit. So can you see the link right here? Wait. Oh no. No screen. No screen. No screen. I'm gonna be good. We're gonna get it. Yeah, all right, there we go. So hopefully that's readable. All right, so check out my repo. The branch is important, and the folder that you'll find the code in. Sorry for the QR code. I didn't test it, quite frankly. I just ran QR and code, and it was supposed to come out okay, so I guess that didn't work. All right. And if you have questions, reach out on the GitHub. I'm actually, I pay attention to what people write on that, so just let me know. Hopefully that'll work. Thank you again for your patience, and have a great one.